Hey everyone, welcome back to the Flow Circuits walkthrough. This is part 4, where we will look at an extremely common application in fluidics, mixing fluids in a chamber. Mixing fluids is important for many applications in biotechnology, analytical chemistry, and industrial processes. And fluidic devices are a powerful way to automate and decentralize these processes at scale. One common method to mix fluids in a fluidic device is called bubble mixing. We achieve bubble mixing by bringing 2 or more fluids together into a common chamber and pulling up bubbles from the bottom of the chamber to induce mixing. Before we dive into flow circuits, it is important to understand that flow circuits is not a CFD platform. CFD, or Computational Fluid Dynamics, is a highly detailed and complex multi-physics simulation of fluid flow, and it has many pros and cons. On one hand, CFD offers a high level of precision, detail, and understanding to answer specific questions of specific geometry. For instance, it is very common in aerodynamics to help engineers minimize drag forces, or in pump design to help engineers maximize pressure head. One of the downsides is that CFD requires you to build a 3D model, which you won't always have in the concept stage of a fluidic device. The models can often take weeks to run, can be quite expensive, and require highly skilled engineers to set them up and analyze the results for design feedback. Furthermore, CFD does not allow for quick design iteration, scripting, or fluidic sequencing, which is needed to fully understand a dynamic fluidic system. However, if you do need to run CFD on part of your design, contact the team at Flow Circuits and we'll be happy to help. We found that in most cases, Flow Circuits is a more practical solution because it is fast, easy to use, collaborative, customizable, and programmable. So all that being said, considering that Flow Circuits takes a simplified simulation approach, we assume that 2 fluids in a chamber together just mix together. So that is what we will set up in our design now. First, we will need to input 2 different fluids with input chambers. Then we will need to mix them together in a mixing chamber. And finally, let's move the mixed solution from the mixed chamber to an output chamber. Of course, we will need a pump to move things around. And where we have a pump, we need vents. And we will need some valves to control everything. Now let's connect everything up. Now we're ready to test this out. First things first, let's drag and drop the input fluids. Then let's open a valve and pull fluid 1 into the mixing chamber. Now we can switch valves and pull in fluid 2. We can inspect the fluid in the mixing chamber and see the new solution we've created. Flow Circuits calculates the resultant fluid properties for the mixture and shows a mixed color and percentage breakdown to help you visualize your process end to end and understand completely where all the fluids started and finished. Now we can switch valves again to move this mixed solution to our output chamber. Okay, so we've looked at the common process of mixing 2 fluids. Stay tuned for the next video where we will expand our design in the 3rd dimension by designing across multiple layers.